After cleaning your data, the next step before visualization is consolidating it correctly. In this lesson, you'll learn why flattening data with Excel-style lookups causing problems like redundancy and scalability issues, and how Power BI data modeling connects multiple datasets properly to handle large data, enable analysis, and support accurate reporting. Let's dive in.
What is the next step? So the next step is
Visualize.
before visualization, you have to do a few things. You do data, you actually have to consolidate the data, right? Your data,
Is this where we're building the model?
correct. And I
Or
also
yeah.
want you to see a few things now, especially for people who come from an Excel background. Let's say from here, when now we have after this after this data transformation, we have three data sets which are now clean, right? We have found all the issues and we have removed all the issues together. We have removed all the issues. Now the data does not exist in one single place. So you consolidate the data. What do? You say, okay, I want, 5 columns from this data set. I want 10 columns from here, and I want 5 columns from here. So you basically in Excel, you do a lot of VLOOKUP, right? This is where you do VLOOKUP or index match or HLOOKUP, X, Y, Z. You basically do data flattening. Does it make sense? You flatten the data set. Why do you do data flattening? Like what's the harm in data flattening? What are some of the problems in data flattening? Let's make this part a little more obvious so you can start to see that data flattening comes with it with some of the problems.
You typically would lose a level of detail that you have in the raw data.
You will lose a level of detail. It can be true, but not necessarily true. Depends upon how you are doing the data flattening. But consider this: when you bring all the data in one single place, it in a way it's like data explosion, right? Just to make it more dramatic, you're bringing everything into one single flat file, and that one single file becomes enormously big. And Excel is terrible when it comes to handling big data. Excel struggles to work. Another thing to another thing to consider here is data redundancy. Data redundancy. What I mean is when your data goes from a small data set, right? Let's say you have Sydney and Melbourne, right? When your Sydney comes here, Sydney, which was only written once, repeats itself, right? Because normally you move your data from a lookup table or a reference table into a transaction table. That's the normal behavior. So a data which was recorded just once, a data which did not have any duplicate in one data set, suddenly starts to have duplication, data redundancy. You also have scalability issues. You have this flat file, and let's say in the future you have another requirement. So it means adding more columns into it. So a flat file reaches a stage where you cannot just add more columns to it because now it's just become too big. So it becomes extremely difficult to scale it. So you just have to do a lot of rework. You have to just start from the scratch. So you have scalability issues. I'm just going to write a few things, and if it does not make sense at this point, it's okay because once we actually see the solutions of the problem, it will make more sense. You cannot flatten two transaction tables. Now, I don't expect this point to make sense right away, and if it does not, that's fine. We are going to discuss it. You cannot flatten two transaction tables, and that is one of the challenges that you will face. Some people come from, supply chain and procurement background. You have an inventory transaction table, and you also have a sales transaction table. You cannot bring the columns from one transaction to another transaction. It will affect, it will cause duplication. It will make your calculations incorrect. So data flattening has some of the issues. You might be able to understand some problems quickly, and some problems are are not very understandable at this point, which is fine. So once you see another way of doing data flattening or data consolidation, so what we say is okay, I don't want to flatten the file. There's a better way of doing it. I'm going to keep these files separate. I'm going to keep these data sets separate, and I'm going to connect them with each other. Instead of flattening, I'm going to do data model. Instead of data flattening, I'm going to do data modeling. Now, data modeling reduces redundancy. It's highly scalable. It's highly scalable because now I can add more data sets. And once I know what I'm doing, I can start to form more connections. More connections. It's almost like you can think of it as a living entity. It keeps on growing as you get more mature. It's not like you're going to start from the scratch every time. You can handle big data sets, right? Just to provide you some perspective, 1 billion rows of data can be handled. It's much bigger than what you can handle in Excel. And then at the same time, you can you can compare across different transaction data. You can also compare across different transaction data. You can do something like, comparing my inventory quantity that I have on hand, and I can compare it with how much sales is happening. So these are two different transaction data set that I can compare across, which provides us very meaningful insights. You can compare your marketing campaign and effect of a marketing campaign on the top line. You cannot actually do these kind of things in a flat file. So data flattening versus data modeling. The step actually is you consolidate the data. But how do you do it matters. You can either flatten or you can model. Okay. Let me stop here. If anyone has any question, please feel free to shout out.
Just in from my background, this would have been called like third normal form. I don't know if you've come across that.
Like normalization, you mean?
Yeah, exactly. Normalization and sort
Okay.
of remove repeating data. And
Remove repeating
is
data.
that what we're saying? Yeah, is that what we're
James,
saying here?
James, great question. And let me actually clarify a few things.
Hmm.
We have people who come from more IT background, right? I'm going to make some generalizations. So apologize if that's not exactly what happens. So IT, people who come from IT background. People who come from IT background, they work with something called a databases, right? They understand things like database design, database architecture. Whenever they work with databases, everything has to be normalized to the smallest point possible. So idea is removal of all duplication. Now databases are optimized for speed of transactions. That's the intent of a database. Create a new record, delete a new record, edit a new record, etc. So that's why they are optimized for speed of transaction. On the other end of spectrum, we have business users, right? And business users just work with a flat file. Like everything for them is a flat file like this. They convert everything into, and we call it a denormalized. A flat file is a highly denormalized. Every column is in one single place. And when something becomes denormalized, you have duplication. What is the intent behind denormalization? Why do we do it as a business user? Comprehension, basically. Just easier. Correct? There's no other good reason to actually bring everything into one. It just becomes easy to read and ingest and perform analysis on top of it. It's comprehension. And in IT, everything is actually broken down into smallest possible piece, right? It's this. A data model is a sweet spot between a highly normalized database and a denormalized highly denormalized flat file. What is the intent of a data model? Intent of the data model is analysis. Intent of the database is speed of transaction. Intent of a data model is analysis. So you need some clarity of what the end result looks like. What do I want to track? And from there, you understand and design a data model. You know, another way of thinking about this, your data model is also like a local data warehouse. And that is also a distinction between a data warehouse and a database. Your database is the speed of transaction. Your data warehouse is designed to serve the analysis purpose. A lot of what you have to understand when we are designing a data model is when to flatten and when not to flatten. That's what you will understand. You know, when do I combine the data sets together where it makes sense, and when to keep it separate and connect, when to flatten and when to form a relationship. That's how you kind of understand the balance between a database and a flat file. It's a very long answer, but James, I hope it kind of provides you some perspective.
Thanks for that.
No problem. Okay, and I hope this answer will also resonate with the business users here. Because when you think, because you don't have to take either of the extreme view. At times we are going to merge and flatten the data sets together, and at times we are going to keep it separate. And that's why it's not a strict science. You have to understand the final result and the final output before you can make these kind of decisions. So we are going to get back to these points once we are inside the data modeling. Okay. So that's your data consolidation phase.